In this video, you are going to learn how to define a work. So let's begin. Defining work. The work done by the force is defined as a product of the force in the direction of the displacement and the magnitude of the displacement. Now let us consider force F in the direction of the displacement and the displacement is d. Then the work done by the force is defined as work done is equal to force times displacement. So as you can see, F is my force and d is the displacement, so we will write w is equal to vector f dot vector d. Now let's try to understand what actually this means. So let us consider a force F is applied at an angle of theta with the direction of the displacement d. Now in order to explain this, what I'm going to do, I'm going to consider a diagram. So this is the surface and this is the object. Let a force F is acting on this object and let's consider the horizontal. So this is the horizontal and let this force F is making an angle of theta with the horizontal. So basically we have a force F acting on this body which makes an angle of theta with the horizontal. Now let's consider the horizontal and the vertical component of the force. So if we consider the horizontal component, which will be this component right here, and the horizontal component of the force will be F cosine theta. Now the vertical component will be this force and the magnitude will be F sine theta. As we know that the body is moving from here to here, so basically the horizontal component of force is responsible to move a body from this point to this point and let the displacement is d. So basically the change in position between the initial and the final position of the body is d. Then the work done is equal to F cosine theta times d, because we are considering a force in the direction of the displacement, and if we simplify further we will get W is equal to Fd cosine theta. Now the magnitude of the work depends on the cosine theta, so let's consider all the different cases. So our first case is when theta is equal to 0 degree, then cosine theta will be cosine 0 and that is equal to 1. So our work done will be W is equal to Fd and my cosine theta is 1. So we will multiply Fd times 1 which is equal to Fd. So when theta is equal to 0 degree, the work done is basically the multiplication of force and displacement. Now let's consider a second case. So when theta is equal to 90 degree, then cosine theta is equal to cosine 90 and we know that cosine 90 degree is equal to 0. So the work done is equal to Fd times cosine 0 which is 0. So Fd times 0 is 0. So work done will be 0. Now let's consider a third case. When theta is equal to 180 degree, then cosine theta is equal to cosine 180 and that is equal to -1. Now let's substitute this value, and if we do that we will write W is equal to Fd times -1 and that is equal to negative Fd. So when theta is equal to 180 degree, work done is equal to negative F times d. And this is how we will define the work.